All right, 6.7, average value of a function. When you find average velocity, what does that mean?
The average speed of
Yeah, it's like the average speed between two times, right? And what kind of line is it? That's the part that I care more about.
secant or what?
It is a secant line. Why are you cussing over there? All right, so how have we found the average velocity so far? Well, we found the position at B minus the position at A over B minus A, or technically position of A minus position at B over A minus B, right? They're both true. Doesn't matter. Usually we do the first one, but technically they're both true. Huh? It's not even this. It's kind of like that, but it's not the full thing. No. What about average acceleration?
The same thing but with velocity.
Exactly. Same thing, except we use the velocity function. So V of B minus V of A over B minus A, or the opposite. Well, we're not going to write it, right? But we could do A minus B over A minus B. Okay. Amazing. That part should make sense, yeah? These are just slopes of secant lines. All right. If P of T, V of T, and A of T represent position, velocity, and acceleration defined at any time T, write an equivalent expression for each of the following integrals based on the fundamental theorem of calculus. So, if we are going here from A to B, what does it mean to be 1 over B minus A? What do you think that means?
The inverse. No.
Well, it would be like, it's just a constant right now. So it's not an inverse or anything. It's just a constant that's going to be in front. And then here, I would have to do the integral. What is the integral of A of T?
V of T.
V of T. Yep. And it would be from B to A. So that means it would be V of B minus V of A. What did I just write? The average acceleration, right? If you look at this, right, that is exactly what we wrote here for average acceleration. So that is the average acceleration. Now, why is that important? Because that means that this is another way for you to find that, right? So if I integrate acceleration and I'm doing it from A to B and I multiply it by 1 over B minus A, I have effectively found the average. So it is another way for us to find the average. Right, Ariane? Excellent.
What?
So when we did this, when we integrated from A to B, we end up with this part.
Yeah.
And if we're multiplying it by this constant, which are the same two bounds, ultimately we end up with the formula that we took for the average acceleration. So it's just another way for us to write the average. So this one is going to be what?
Average velocity.
The average velocity. What'd you say? Okay. Yeah, exactly. Oops, B minus A. Exactly. It's the same thing, except that this is going to be P of B minus P of A, and it is the average velocity. Hey, Miguel, who was just talking? Exactly. Always blaming everyone else.
But it is true most of the time.
I agree. I agree with you most of the time. All right, the average value of a function f of x on an interval from a to b, therefore, can be defined as 1 over b minus a of the integral from a to b of f of x dx. Oh, f. Okay? Esteban, what's wrong? You want to hit him with an eraser? No, it's just f. That's just f of x. It's just got a funny little lightning bolt symbol. I don't know why. There we go. Better? Excellent. So, find the average value of this function from 1 to 3. Well, that means that we're going to go 1 over 3 minus 1 of the integral from 1 to 3 of my function x cubed square root. Square root of sine squared is just sine. That's weird. Yeah, it's kind of a waste of our time, so let's just write that. Right?
Miss.
Unless that's supposed to be the third root and it's not x cubed. I don't think so. I'm going to go with it's x cubed. It looks more like x cubed. All right, and then dx. Now, do I know how to do that yet?
No.
Nope. Get out your calculators, right?
What's the
Calculator. So do you not have a calculator? It's like
All right, so let's see. It was 1 over 3 minus 1, which is 2, times
Integral.
the integral from 1 to 3 of x cubed
Sin x.
sine of x dx. So I get 5.848.
Why is it with the squiggly lines and not with the...
It shouldn't be the squiggly lines.
Mr. Aguardo.
You're absolutely correct.
Times the integral or just the integral next to it?
It's the same thing. It means times. Yeah, it means times. Any, make sure you guys can do that on your calculator. Elias, what are you watching? What are you doing? You've missed a whole bunch of school. Turn it off. Yeah, but you can still write it on blank paper. Come here, I'll give you paper. All right, so the next one then. No, because when we evaluate an integral, like a definite integral, c goes away. So we don't have
I
to.
didn't get that.
You didn't get this, then you put it in your calculator wrong. There's no other way to go about it. You just put it in your calculator wrong. Because if I have the square root of sine squared, what is that? Yeah, it was kind of weird that it was written that way.
Oh, but you cannot do this one by hand.
Not until BC, because you guys don't know how to do integration by parts. So not yet.
By parts. So
Don't worry about
essentially, no, I have a question.
Yeah.
Essentially, if I were to plug into the integral, o sea, to the antiderivative of that equation, 3, and then minus the minus 1, and divide it by 2, it will give me the answer. But
Yep.
I don't have to do that
Because you don't know how yet. Yeah. So we just put it in our calculator and get the answer for this, which is like 11 or something.
the whole process.
Okay, so now we're going to find the average value of this function. Ladies. All right, this one we're going to do without a calculator. So, this one's going to be 1 over 4 times 2x minus 2x squared. How did I get 2x squared?
You found the antiderivative.
Yeah, right? 4x squared divided by 2 is just 2x squared, right? All right, and then I'm going to evaluate that from 6 to 2.
Okay, está bien.
What's the problem, Miguel? What? So 4x squared over 2, right? 4 divided by 2 is just 2. Okay, so now, you're right, I should have technically put C. Now we evaluate that from 6 to 2, so that's going to be 12 minus 3672 minus 4 minus 2, 4, 8.
You plugged in first the 6.
Yep, plugged in 6, then I plug in 2, right? This
So it's
is,
always the greater number first.
yep, always. 12 minus 72 is negative 60. 4 minus 8 is negative 4. Minus negative 4 is plus 4. Which means I'm going to get 1/4 times negative 56. Why can I not do that in my head? 14. I was like, why is my brain not working?
Mister, I'm scared.
What are you scared of?
I'm scared that in the test I'm not going to be able to do this kind of quick math, and I'm going to lose time on the test.
So just write it on the side. Just literally go like 56 divided by 4. 1.
I don't know how to do long division.
Well, that's something we're going to have to fix. All right.
No way.
Oh, sorry, my bad. I thought you were done.
Pero es porque ya perdí mucha práctica.
I'm excited about the next question. It's about a ski resort. Me too.
Stop telling. You know why? Because you do the math quick enough. So I lost my skills of doing quick math because I didn't do it before you. So when you say it, I just
That one took me a while. Well, you have to keep working on it. All right, let's do the ski resort with the snow machine. Ready? Ochoa, you ready?
We're ready.
Excellent, Ochoa. All right, Bean, listen up. Ski result uses a snow machine to control the snow level on a ski slope. Over a 24-hour period, volume of snow added to the slope per hour is modeled by the equation S of t. The rate at which the snow melts is modeled by M of t. Both S of t and M of t have units of cubic yards per hour, and t is measured in hours from 0 to 24. At time 0, the slope holds 50 cubic yards of snow. Compute the total volume of snow added, only added to the mountain in the first 6-hour period. Well, if this is how much is added, I would simply need to integrate from 0 to 6 my S of t function. So 24 minus t sine squared t over 14 dt. Now, I cannot do that in my head because it is a product and chain rule. Actually, it's a double chain rule. So to reverse those, we don't know how in AB. So we're going to put that into our calculator instead. So,
We only know to reverse polynomials, right?
yeah, exactly. And technically, like, simple trig, cosine sine. All right, so it was the integral from 0 to 6
¿Cómo se hacía eso?
of 24 minus x
Mister, how did you do the math? What?
sine of x divided by 14
Mari, ¿cómo se hacía math?
squared dx. Guys, when you're putting this in your calculator, be careful, right? You cannot put sine squared in most of them. You need to actually put parentheses around it and then square the whole thing.
Sir, but I am going to put the equation of S of t, like if I put like S6 gives me the amount of snow added on the 6th hour or the total amount of snow.
The total. The integral means that you're summing from 0 to 6.
So then it is easier to just put S of 6 instead of
No. You'd have to find the function first. And you don't know how to find the function. So that's why. It would be the same amount of work, but you don't actually know how to find the function yet. Now, if you have a TI Inspire, it'll do it for you. But the TI 84 won't. Okay, so it was 142. I already forgot. 0.41. 413. And that was in, what are we measured in here? Yards. So yards cubed. Now it would not be per hour because this is over the 6-hour period. Guys, there's way too much talking still. Okay. So,
Mister, I record it negative.
you plugged in something wrong, yeah. Yeah, you just plugged something into your calculator wrong. All right, find the value of M of t and the average of M of t over the 6 hours. So M of t is going to be the total amount of snow that melted, right? What was M of t? 10 plus 8 cosine of t over 3 dt. Using correct units of measure as well. Let's say what that is. So this one is going to be, this time it's the integral of 10 plus 8 cosine of x divided by what?
3.
Divided by 6.
Okay, now what is it divided by?
6.
No, it's by 3. So 81.823.
Pero todo es divided by 6, mister.
Later. We're not doing that one.
No, it can't.
All right, and that one would be yards cubed. Specifically, explain what this means. This means it is the total melted
So what did I do wrong?
snow
Mister,
in 6 hours. Well, I shouldn't say that. In the first 6 hours.
No, that's
Mister, could you go back to Desmos? Can I see what you put in there?
That's the same as total. Accumulated amount of snow is the same as the total amount of melted. I said you could use both. I said you could use both. In the 6 hours. All right, now let's find the next one, which Tomas already correctly said. That's just going to be the average per hour, right?
So can't we just grab that number and
Absolutely. So what we're going to do to kind of shortcut ourselves here because we know what this is doing, is we're just going to say that it's 81.823 over 6.
In the what?
Which is going to give us 13.637. And that's going to be yards cubed per hour. And this is the average melted snow per hour for the first 6 hours. Right? Because if the first one was how much snow melted in 6 hours, when we divide it by 6, it's just saying, hey, it was roughly 13.637 cubic yards per hour. Now, does that mean that's actually what it was? No. Right? Chances are it was less at 0 and more at hour 6. I don't know when hour 0 is. It might be midnight. But regardless of whether it's midnight or 6 in the morning or 8 in the morning when they open, whatever it is, it's going to be warmer 6 hours later. So therefore, most likely it actually melted more in the 6th hour. But we can still find the average. It could be colder if for some reason hour 0 was like closing time, but that seems unlikely.
From like 5 to like 11.
Exactly. It's unlikely, but yeah, it could be. You're right. The hell was that?
Mr. But for now,
All right, let's. We're not done? Okay, I'll let you keep writing.
so here we plug in which one?
For what?
Or we don't?
For C?
Yeah.
We're actually finding. Well, just wait. I'll get to it.
As of 4.
All right, you guys ready to look at C? Ladies, stop talking. It is constant. Okay. Is the volume of snow increasing or decreasing at time 4? How would I figure that out? Let's start with the justification. It tells us what to do. It's going to be because what?
The sign
Of
the volume of
which would be like the acceleration.
Yes.
Because the derivative of the volume is positive or negative.
So we're going to have to make a new function, but yeah, so it would be the because a prime of t is either positive or negative. We're going to leave it for now.
Why did you call it A?
Well, because you'll see in a second.
Porque va a ser como la aceleración, pero
Because right now I need to know the total volume. Do I have a function for the total volume?
You need to add 2. Like,
I do not. So the total amount is going to be what?
how much you add minus how much you take.
Exactly. So this is going to be S. Sorry, no. It's also there's a certain amount that started there, wasn't there? Yeah, 50. So there's 50 cubic yards to start, plus S of t. So the integral from 0 to t of S of t
why the
dt,
integral.
because that gives us the amount of snow that was added, plus the integral from 0 to t, sorry, not plus, minus,
bueno, entiendo porque se puede ver como
the integral from 0 to t of mt dt. Ladies, if you don't understand, panicking and yelling in Spanish is not going to help you. Ladies,
Why are we doing the integral instead of just doing ST?
because that would only give you the amount of snow at 1 hour.
And that's not.
You have to integrate to get the accumulated change. Yes. Ladies, you have to remember that the integral, this is similar, it's not exactly the same, but it's similar to this idea of sum.
Okay.
And in BC, you're going to see we go back and forth a whole bunch. Okay, so we need to do these. Now, in our case, we're finding A of 4. But really, do we need A of 4?
No.
No, what do we need?
The integral.
The A prime of 4.
We only want A prime, because we just want to know if it's increasing or not. Actually, probably what we should do then is just find A prime of t first. Which is nice and easy. 50 goes away. The integral of st is just going to be s of t. Because it's from t to 0. Minus m of t. It's, no, guys, no. Look, it goes away because that's what I said. It's from t to 0.
Yeah.
The only reason it goes away is because we're doing it from 0.
Why?
If I was doing it from like 3, I'd have to actually plug in like s of 4 minus s of 3.
S of 0 plus 0.
Exactly. Like at 0 time, there's none that was added or melted. So it's the only reason I can make them go away. Yes, because it's just t. This is actually another theorem of calculus, which I'm going to go over later. It's a second fundamental theorem. Okay. Anyway,
So then we find
I guess I should also say this was the total snow. I forgot to actually say that that's what that equation was. So this would be the rate at which the total snow is changing. Now we want to find a prime of 4, which is just going to be s of 4 minus m of 4, which is, I don't know, we got to go plug it in, man. Up here, let's have the boys do 4 into s and girls do m. And I already did it, so we'll see if you're right. Although I did the total answer, so I only know if the total answer is right. It should be that it's positive.
because it says here that S of t is equal to
So, but you have to plug in the 4 first.
No.
Yes, I know, and I'm saying it's a theorem. You don't know it yet. Don't worry. It's a theorem. I'm going to show you later.
Sir, I'm getting an
You're not entirely wrong, but I want you to think about it logically. At 0 time, could anything have melted? Could anything have been added? No. So that's exactly. Later on, I'm going to teach you that it's also an actual theorem that helps you understand why it's that. But for now, it's sufficient to just think logically and go, well, clearly it's 0. All right, did you guys get it? Come on. Boys and girls, what'd you get?
4 and 4.
What'd you get?
11.88.
All right, you did the whole thing.
No,
We just did
and 4 is
Okay, and what was S of 4?
I don't know.
23.6822. So the total is negative 58. No, yeah.
So you got 23 point what?
23.622 minus
11.88. Which is, let me see.
Sir, literally giving me 4.
That's going to be like roughly 11.8,
Mister, it's 11.78.
78? So 11.8. Okay, good.
I got 11.8, yeah.
All right, what does that mean?
That at the time the value is increasing because the number is positive.
Exactly. So we can say because a prime of t is positive, the total
So bad, you need some measurement.
amount of snow. I actually don't need units of measurement.
Why not?
The total amount of snow is increasing.
At our 4.
Because all I care about right now, Fabrizio, is the sign. I just need to know that it's positive because I want to know if the total amount is increasing or decreasing.
But then you have,
But otherwise, you're correct. Normally, I should put units. But in this case, I don't need it. I just want to know the sign.
Mr. And
I have a question.
Yeah.
For the function S, it directly gives you the volume of that snow added, right? Why do we need to take the integral of that if it's already given us the volume of snow?
Because that gives us the accumulated change of how much was added.
Because the total.
It's the rate, isn't it?
No. If you read S, it's like directly the volume. At least that's how I understand.
Volume of snow added.
M is the rate, but S I interpret it as directly the volume.
But it's the snow added. Yeah, he's right. It's snow added. So it's like it's a rate.
Que como le va
It's
agregando
look, the key
snow
is in the units.
por hour.
Added to the slope per hours. So if we have amount per hour, it's a rate. The key, often that's the easiest way to figure out if it's a rate already, is just try to understand the units. But I see what you were thinking, because you were thinking it was just the total amount added. So you were thinking it was the function that came before, which it's not, and that's why we have to integrate to get it. Does that make sense now? Yeah. Yeah, it's tricky. Look for the units. It'll help you. All right, so then, how much snow is on the slope after 5 hours? Well, I'm just going to use that same function, but I'm going to this time find a of 5, not a prime, and I'm just going to work it out. So that one, it was 50 plus s of 5 plus, or minus, sorry, m of 5.
Don't you have to integrate?
Yeah, because
Yeah, you're right. The integral from 0 to 5. Integral from 0 to 5. Yes, I do. Thank you. Oh, I deleted them, didn't I? I already deleted them. Well, I have one of them. I have one. So it should be 50 plus the integral from 0 to 6 of... Oh, it's 5? Sorry. It's because I did 6 in the last question and I just didn't change it. My bad. All right, and what was it? It was of 24.
Minus x sine of x divided by 14. Sine of x divided by 14 squared.
Oh, like the...
Yeah, the sine is squared.
Gotcha. My sine is squared. Dx minus that amount.
Miss, you can tell me. I'll tell you.
So I'll expand this so you guys can see it. So that's what you should be.
120.
That's what you should be putting in your calculator. Okay, you should be putting this in, and that gave. I already forgot. 95.335.
I didn't get that.
Try it again.
this, the first integral is it an s or a 5?
It's s of 5.
I thought it was 5 times 5.
Yes, I know you hate my s's.
Yes.
You have to write dt there.
Here? Yeah, I technically should. Yeah. When it's a calculator question, I'm not gonna lie, I'm sloppy. But yes, I should write dt. You're right.
We didn't get.
If you didn't get it, you guys, you got to put it in your calculator again because you probably didn't put it in right.
No. Like, we didn't get.
All right, so the last one then. Suppose the snow machine is turned off at T10. Write but do not solve an equation that could be solved to find the time k when the snow would all be melted.
Integration of 10 to
So if we think about like a of 10 is first of all what we're going to need, right? That's how much snow there was there. And then we're going to subtract the integral. What's the only thing happening after 10? Melting. So it's going to go from 10 to some time k, because they told us to use k, right, of the melted function. So of m of t dt. Said we don't have to solve it, but that's what it would be. Does that make sense of how it would be that?
No.
So a of 10,
So,
listen, no, yeah, sorry, equals 0, yeah, because we want it to be equal 0, yes. So a of 10 is the total amount of snow there after 10 hours. Then we need to subtract, right, or we could have made it equal to this, the amount that melted from 10 hours to k hours. Because we don't know how many hours it's going to take, but we know that like it's going to be, that's the only thing happening. There's no new snow added. And so then it would be like this. Or you could say a of 10 equals the integral from 10 to k of mt dt. That would also be correct, right? They both would work. Any questions, or does that make sense? All right. All right, here we go. Next one. From the year I graduated. Yeah, metal.
oh, you did one practice. That year you graduated from school.
2003.
That is not old. It's already older than you.
Whew, thank God. All right. Guys, we're not going to be able to do it if you're talking. Because once again, you're just not going to know what's going on. Camila. Emilio.
Okay.
All right. So
Okay.
AP Calculus problem number 3 from their exam, which means you can go look up the answer key if you want. Okay. The rate of fuel consumption in gallons per minute recorded during an airplane flight is given by a twice differentiable function and strictly increasing function r of time t. The graph of r and a table of selected values of rt for the time interval from 0 to 90 are shown above. Use data from the table to find an approximation for r prime of 45. So what's that? What am I doing first?
Taking the two numbers.
Between 40 and 50. The two numbers that are closest to it, which are 40 and 50, and we're just going to find the slope of the secant line, right? That's it. So we're going to go r of 50. I guess, you know what? Let's write it like better. Let's say r prime of 45 can be approximated by r of 50 minus r of, they had 40, right?
Yeah.
Okay.
Minus.
Just because we have to use the ones that are in the table, right? So then we can go look. So r of 55, or 50 is 55. R of 40 is 40. So it'll be 55 minus 40.
Over 10.
Exactly. Over 10,
1.5.
So 50.
which is going to be exactly 1.5. Good. So we got 1.5, and that would be what? Gallons. Is it in minutes?
Yeah.
Yes.
Yeah, it is. Good job. Gallons per minute. We're done. All right, let's find B.
That's suspiciously easy.
They often are. So, you have a question?
The original gravity is the rate of fuel consumption. So what is that? The rate of the rate.
The acceleration. Yeah, of the rate of fuel
So
consumption.
the units change.
For the acceleration? It's going to be the
This
gallons per minute squared. All right. The rate of fuel consumption is increasing fastest at time t equals 45. What is the value of r double prime of 45? Explain your reasoning. Okay, so we're saying that it is increasing fastest at t equals 45, which kind of makes sense if we look here, right? That's when it would have, like, if we're thinking about slopes, that's when you would have the steepest slope, right? So that does make sense. So let's see. What is the value of r double prime of 45? I don't know why I turned it into a 90. So we know that this needs to be 0 because r prime of 45 has a relative max. Or the easier one to understand is and r of 45, which is the graph that we have there, right? R of 45, what does it have? If you look at that point there, what is that point right here?
Steepest.
Which is what? What's its?
It's a changing concavity.
It's changing concavity. So it's a point of inflection, right? If it has a point of inflection, that means the r prime is going to have a max or min, which means the second derivative is going to be 0. So the second derivative of 45 has to be 0.
What?
I mean, sir, hold on. You like.
What did I do? What's wrong? So C, approximate the value from integral from 0 to 90 of rt dt using a left Riemann sum with 5 sum-intervals indicated by data in the table. Is this numerical approximation less or greater? So let's start by just actually doing that. So the integral from 0 to 90 of rt dt can be approximated. Now we gotta go look, right? So our first one is going to be 30 minutes wide by our left hand, which would be 20 high. So it's 30 times 20 plus our next one. I think the rest of them are all 10, aren't they? Nope,
No.
they're not. So 10, 10, 20. Yeah, so this one's 10. A width of 10 times what's our height?
30.
30 this time. Plus a width of 10 times 40, I think it was.
Yes.
Plus a width of, it was 20 times what?
55.
Times 55. And what's our last one then? What's the width of the last one there? 20 again? Yeah. 20
Times 65.
times 65. And then we just work out what all that is. So let's see, 600 plus 300 plus 400 plus 1100 plus 1300.
How do you know?
Guys, this is probably not a calculator question. That's why I'm doing it this way, right? If they give you that data in there, you don't, like, so far we haven't needed a calculator, so that's why I'm doing this by hand. Because most likely this is something you'd have to do by hand. So I put all that together. 1, 2. Say what? It's just a Riemann sum. So this is the width times the height, and it's the left-hand one that we took the height from. So that's going to be 1,000, 2,000, 3,000, 34, 3,700. 3,700 gallons. Now, if we look at our graph, what do we think this is going to be, an over or under? So we're doing the left hand. So we went from here over to 30. Then like this, then like this, then like this. Pretty clearly an under, right? Very obviously under. This is an under approx. And I would just say, look at the graph. Like, that would be my reasoning here.
What?
Just look at the graph. And
Sir, can you like sketch on the graph like on the AP?
yeah, I just did. I didn't bother putting the down lines, right? But this is the sketch.
But in the AP exam,
It's digital.
If it's digital, you won't be able to actually sketch it, but you'll still be able to, like, put, like, the line there. You should still be able to put a line on it. Right? Because usually it's just like Khan Academy or any of the other ones where you can draw on the problem.
I'm
So you should
sorry,
be able to.
why would it be an under approximately? Because you're doing left.
Yeah, because I'm doing left, and you can see that when I draw this, I'm not including a whole bunch of stuff here. Okay? All right, D. For 0 to 90 minutes, explain the meaning of the integral from 0 to b RT dt in terms of fuel consumption for the plane. Explain the meaning of 1 over b, 0 to b in terms of fuel consumption for the plane. Okay,
Average fuel consumption.
so the first one, this is just the fuel consumption. That's going to be average eventually, but what's the first one?
The fuel consumption at time B.
At time b, exactly. So this, from 0 to b of RT dt, is just the fuel consumption from 0 to b minutes. So this is full fuel. God, I can't spell fuel. There we go. Fuel consumption from 0 to b minutes. And 1 over b from 0 to b RT dt. This is going to be the average fuel consumption in gallons per minute over b minutes. I guess we should probably put up here fuel consumption gallons
Why over the minutes?
per minute. Huh?
Why over the minutes?
No, that wouldn't be gallons per minute. That would just be gallons.
yeah,
Yeah, I was like, wait a minute. Just gallons. Thank you, Ariana. What did you ask, sorry?
Why over the minutes?
Because we're finding the average. And so when you're finding the average, you're finding a unit rate. So how many gallons per minute, per hour? So it's because it's a unit rate. All right. Shall we break?
Yes, break.
Yes, but leave it there.
Alrighty. Particle motion. Moving along a straight path, velocity of the particle from 0 to 30 shown in the table. Julia, can you wait? Miguel, later. Mariana. Okay. All right. Selected values of t and velocity at those, and it has a maximum at 20. Yeah. Answer the questions that follow. Okay. Using the midpoint of 5 subintervals of equal length, approximate the value of this, which is what?
The average rate of
The average. All right, let's do A up here because we've got room for it. I don't know why there's a big space, but we might as well do A here. So 1 over 30 of the integral from 0 to 30 of VT dt can be approximated by 1 over 30. That part's not going to change, right? And then this is the part that we're approximating now. 5 subintervals. I'm going to guess it's this much, but let's check. 1, 2, 3, 4. There we go. 5.
5. Yeah.
All right, so I think they're always 3. Yes, all of my widths are 3, or 6, sorry. The half is 3. So I can actually pull that 6 out front. And then I just need all my heights, and it's the midpoint, so it's going to be all those ones in the middle, right?
Yes.
Where are those numbers on the bottom?
Because the table's done poorly. Should be 12.2 or whatever. Anyway, so 7.5 plus 12.5 plus 13.5 plus 14 plus 13. Amazing. 6 over 30 is just 1/5. And then this is what? That's going to be 20, 30, 40, 60, 70.5. Yeah. How do I do that in my head? 7.5 plus 12.5 is 20, 30, 40, 50, and then, oh, hang on. 20, 30, 40, 50. That's wrong. It should have been 60. See? Look at that. Because then I did 3, 4, and 3, which is another 10, and then 0.5.
I want to have your friend.
Well, I mean, it just made a mistake, so. Anyway, that would be 12.1. Yeah, that should be 12.1. All right, what would my units be?
Meters per second.
Just meters, because I integrated. So the meters per second becomes just meters, right? Because I go back to the position function. Alrighty. B, find the average acceleration of the particle over the interval from 6 to 18. What does it mean if I'm doing average? NOLA, it doesn't have to mean secant line anymore. What could it mean here? It could also mean like 1 over 18 minus 6 or whatever, right? 6 to 18. I think in this one, it's going to be easier, though, because we don't have an equation to just do the secant line. So it's actually easier to still do that secant line version.
Oh, Mr. Brad, I think you skipped.
What did I skip?
Explain the meaning of the value. I don't see it written anymore.
Oh,
Let me
explain
help
the
you
meaning
out.
of it.
It's the average.
Somebody should figure it out.
All right, so she's going to help me out, but she's not going to give me the full answer. Anybody want to help her out? Average distance traveled from 0 to 30 seconds. Seconds. Isn't it seconds? Yeah, seconds this time. Mariana, that was great. Okay.
Let me help you out with this.
Okay, find the average acceleration. You're right. You're right. I didn't give you any time to copy that down. My bad. Yep.
Sir, when does the equals go out?
All right, so we just realized we had a slight error, so let's change this. This should be meters per second because it's the average, and this is the average distance traveled per second from 0 to 30 seconds. Thanks for that, Nacho. All right, then we can go on to B, yeah? And this one was just a secant line question. So we're going to find V of 18 minus V of, not 9, 6, over 18 minus 6. V of 18 is 14.1. V of 6 is 10.1. And it's over 12.
So just be 4.
Claro. Can you go?
Just 4.
Claro. 4 over 12. 1/3. Oh, correct units. Meters per second squared, because it's an acceleration. All right. Do I need to explain what it means?
Let me express your answer. No, you
No,
don't.
I'm good.
Express your answer using correct units. That's the thing.
Okay, we're good this time. All right. Find an approximation of v prime of 6. Using correct units, explain what this value represents and state, providing justification if the speed of the particle is increasing or decreasing. Okay. So if I'm finding it at 6, I'm going to have to use the 2 points around it. So that would be v of 9 and v of 3 over 9 minus 3, which is going to be, I don't know what 9 and 3 are. 9 is 12.5, 3 is 7.5. So 12.5 minus 7.5 over 6, which is 5/6
Yards.
meters per second squared. All right. What is
And
that?
also explain if the value represents a state.
Yep. So first I got to explain what it means. So that would be our average acceleration at t equals 6. Provide justification if the speed of the particle is increasing or decreasing. That's a weird way to say that, but whatever. So this would be that, let's see, we would probably say v prime of 6 is positive. V of 6 is also positive, right? Therefore, speed is increasing, right? Because they both have the same sign. Yeah?
Yes. Yeah.
You guess?
Yeah.
Uh-oh. All right. D, during what interval of time is the acceleration negative?
This is like.
This is all a theory question. Read the question again and you'll figure it out, I think.
During what interval?
No, no, this part. Read the introduction to the question.
Is it from 21 to 30?
From 20 to 30.
Kind of. From 20 to 30 is a better answer than 21. Basically, anytime after 20. Immediately after 20, because if that's a maximum, right? If the velocity is a maximum, it's increasing to 20, and then it's going to start decreasing, which means that if it's decreasing, the acceleration has to be acting against it.
You have to justify your answer.
Well, yeah, I just did. But now we can write it. So we're going to say after.
But you cannot be sure. You could be at your max.
It's true, but based on what they gave us, probably not. Because t equals 20 is a max in velocity.
Therefore.
And exactly. Therefore, it's a max, not a mass. It does not have a tumor. Because I think, didn't it tell us it's a strictly increasing function? Or was that the last question? That was the last one. Okay. And therefore, since velocity is slowing down,
After that.
acceleration must be the opposite sign, which is negative. Opposite sign to velocity,
We have finished.
negative. We have finished with 2 minutes.
Mr.